AI-driven medical imaging is pushing boundaries. But here's the challenge. These workloads demand massive storage performance to keep up. What if you could scale without limits? From segmenting organs in seconds to generating synthetic datasets that expand research while protecting patient privacy, healthcare IT teams need a solution that's fast, scalable, and secure. That's where Pure Storage and NVIDIA MonAI come in. Let's take a look at how FlashBlade accelerates AI-powered medical imaging. Medical imaging is transforming patient care, but AI-driven workflows come with major challenges such as huge datasets, real-time inferencing, and strict privacy requirements. Pure Storage and NVIDIA MonAI are solving this with a high-performance, scalable architecture built for medical imaging. Today, we'll walk through how FlashBlade powers AI-driven segmentation and synthetic data generation, helping clinicians get faster, more accurate results. First, a little primer. We're going to be dealing with two specific NIMs in the MonAI framework. The first one is Vista 3D, which does interacting labeling of up to 127 different anatomical classes, and it combines automated and manual segmentation for enhanced accuracy. And then the Maisie framework, which is going to generate high-quality synthetic 3D CT images so that you can expand your datasets while safeguarding patient privacy. We'll begin by looking at the Vista 3D. Now, in a lot of medical imaging use cases, you might have several CT scans that you want to automatically segment for organs or tumors, and here we're going to actually walk through one of those use cases. So we're going to start our NVIDIA inferencing NIM. We're just going to grab one of the many images that we have here to work with, and then this image, this function here is going to plot it for us. So here we go. We're going to look at that image. And here is that CT scan. So obviously there are many, many slices to this. You can think of this as a volumetric scan, but we're going to focus just on these three different views, the sagittal, coronal, and axial view. Now what we're going to do is actually take this whole volumetric image and actually segment one of the specific organs that we're interested here, which is the spleen. Now, as I mentioned before, we can segment up to 127 different classes, but just to show you how quick this can be done, and all being powered by a Pure Storage FlashBlade, well, we run that, it takes roughly about 2 seconds, and then we're going to plot the image path, which is shown here in orange. So here we're actually labeling the spleen along those three different views that I told you about. And furthermore, if we actually think about the whole image, the whole movie of that image, here is this GIF that's going to be playing that's going to actually be segmenting throughout the entire body that spleen for doctors to use for drug tracking or tumor detection. As you can see here, it starts over here on the right. But as we go through the whole body, it actually starts slicing each of those individual organ pieces for us. Now here we actually have the Maisie image, the Maisie diffusion image generation. What we're able to do here is actually create new CT images. This is going to augment medical imaging use cases, particularly for use cases where you're missing labeled data. So we could actually go here for chest and look at one of the many different organs that we could segment, and you can segment many at once. So we're actually going to look at a generated image. We're going to look here at the chest CT. Takes it a second to load. And we could actually slice through it like we were able to see before in that GIF in the Vista 3D. But more importantly here, when we actually click the load segmentation label, so what it does is it generates a unlabeled CT image, and then it gives an additional file for all of the different classes that we're interested in. So here it's going to do all 127, so you actually get to see all of the different vertebra labeled differently, different parts of the kidneys, the lungs, etc. More importantly, this is actually all going to be powered by a Pure Storage FlashBlade, so you can actually scale this out to hundreds and hundreds of different CT images passing through and being inferenced all at the same time, so you can get a faster response back to your medical doctors. Speed and scalability matter in healthcare. Whether it's segmenting organs in real time or generating synthetic datasets to improve AI models, NVIDIA MonAI and Pure Storage FlashBlade make AI-powered medical imaging faster, more efficient, and ready to scale, all while keeping patient data secure. And if you want to see more ways Pure Storage is helping organizations work smarter, check out Pure 360. It's your hub for quick overviews, expert walkthroughs, and interactive demos, all designed to simplify your infrastructure and help you achieve more.